In this quick presentation, I'm going to cover two main networking models that are in common use today. The two models that we'll be covering are the OSI model and the TCP/IP model. First off, let's cover the OSI model. The OSI model was designed for the specific purpose of better explaining the whole networking process. Each layer focuses on a different component that makes up the entire networking process. One good way to remember the different layers of the OSI model, and one way that's always worked for me, is to come up with a phrase that incorporates the first layer of each layer of the OSI model. For me, one that I've always been able to remember it is, "Please do not throw sausage pizza away." And now that I've told you, you probably will never forget it either. Let's discuss the OSI model from the top down, starting with layer 7. Layer 7 is the application layer. It's the layer that resides closest to the user. In fact, this is the layer where the user directly interacts with the OSI model. Any applications that they run, whether it be a web browser, a mail client, those different types of applications use a specific protocol that the user directly accesses. So things such as SMTP or HTTP, those are protocols that would rely on the application layer. Layer 6 of the OSI model is the presentation layer. In this layer, data is transformed into a form that the application layer can accept. The presentation layer resides in between the application and the session layer. Encryption would be an example of something that could be categorized to fall into the presentation layer. Layer 5 of the OSI model is the session layer. This layer deals with connections, specifically connections between computers. It manages those connections, it establishes the connections, and it also deals with terminating those connections. Layer 4 of the OSI model is the transport layer. This layer provides a means for transferring data sequences. It also controls reliability of those communications, and it provides acknowledgments when those communications are successful. Layer 3 of the OSI model is the network layer. This layer provides a mechanism for transferring datagrams, specifically from one node to another on the same network. Unlike the transport layer, the network layer datagrams are not guaranteed to be delivered. Some things that may be categorized as things that would fall into the network layer would be routing protocols, multicast group management. Network layer address assignment also takes place in the network layer. When you're thinking in terms of a device that might fall into layer 3, oftentimes routers are considered layer 3 devices. Layer 2 of the OSI model is the data link layer. This layer provides a reliable link between two directly connected nodes. There are two sublayers that consist of the data link layer. And those layers are the media access control layer, the MAC layer, and the logical link control layer, LLC. Also, what occurs at this layer is that this layer detects when there's errors in the physical layer. It also attempts to correct any errors that may be occurring in that layer. When you want to think of a device that may fall into the category of a layer 2 device, switches are often considered to be layer 2 devices. Layer 1 of the OSI model is the physical layer. This layer defines the connection between the device and physical transmission medium. The copper cable or category 5 cable would be considered a physical layer 1 medium. Also, fiber cable would also be considered a physical layer 1 medium. Now that we're done talking about the OSI model, let's talk about the TCP/IP model and the layers that it makes up. The first layer of the TCP/IP model that we'll discuss is the network interface or link layer. This layer defines how a host connects to the network. It describes the physical media and the method of transmission. For example, when someone refers to Ethernet, Ethernet would be considered a link layer protocol, and it also refers to the cable or the physical media that the device and the communication is going across. The internet layer of the TCP/IP model is where the internet protocol or the IP portion of TCP/IP comes from. Some of the protocols that reside within this layer are the Address Resolution Protocol, often called just the ARP protocol or ARP, and the Internet Control Message Protocol, ICMP, or Internet Group Message Protocol, IGMP. One of the functions of ARP is that it ties an IP address to a MAC address. Let me show you an example of ARP in action. In a Windows command prompt, if you type in ARP-A, it'll show you a list of IP addresses that are tied to a MAC address. Basically what this information is telling us is the computer that I'm on is telling me all the different IP addresses and the other computers that are on the network that it's aware of. So if I ping that computer, that IP address and that MAC address will show up in my ARP cache. The transport layer of the TCP/IP model is where the TCP portion of the TCP/IP model resides. TCP is a connection-oriented protocol, and UDP also falls underneath the transport layer of the TCP/IP model, but UDP is a connectionless protocol. Now that we've discussed the OSI model and the TCP/IP model, let's discuss how those two models relate to each other. Let's line up the two models next to each other. And we're also going to include some common protocols that are considered to be networking protocols. Let's look at the first layer of the TCP/IP model and see how it relates to the OSI model. So if we look, we have the application layer highlighted. Now if we look over at the OSI model, that also includes the application layer, but it also includes the presentation and the session layer as well. And if we look over at some of the common protocols that fall underneath this application layer, we see HTTP, FTP, SSH, Telnet, SMTP, POP, and DNS. So all of these kind of relate to each other, and there's some crossover here. So we see anything that resides within the TCP/IP application layer also resides within the bottom three layers of the OSI model. The transport layer of the TCP/IP model relates to the transport layer of the OSI model. And now if we look over at the common protocols that fall underneath that layer, we see TCP and we see UDP. The internet layer of the TCP/IP model falls underneath the network layer of the OSI model. And if we look over at common protocols, we see IP. So we see that IP falls underneath the internet layer as well as the network layer of the OSI model. The network interface, or the link layer of the TCP/IP model, we can see from here that it also relates to the data link layer and the physical layer of the OSI model. And then if we look at common protocols, we see Ethernet, frame relay, and token ring. So we know that these protocols underneath common protocols all relate to the network layer, or the network interface layer or link layer, and also the data link layer and the physical layer of the OSI model. Hope this little exercise has helped you gain a better understanding of some of the more popular networking models, and I hope you enjoyed watching it as well.